Hello, I welcome you all in this presentation related with the subject failure analysis and prevention. And we have now almost covered the different steps related with the general procedure of the failure analysis, and we have also talked about that how to integrate the various aspects related with the analysis for arriving at the conclusions regarding the causes of the failure. So, analysis of the failure analysis results, this is what we have talked, but in addition to this we need, so what analysis involves, like the information which we have collected from the different aspects, either through the interrogations, to the talking talking to the people, collection of the background information, preliminary examination, NDT of the component, DT of the component, failed component, then macroscopy of the failed component, microscopy of the failed component, metallography, then chemical analysis, fracture mechanism determination, and the fracture mechanics application in failure analysis, and if required then simulated service testing. So, findings as per need, the findings of the different stages of the analysis is used basically for the integration of the results or the information identified through the different stages, integration of the information oblique results obtained through the different tests and different interactions with the people who are involved. So, this integration will help to systematically formulate the conclusions regarding the primary sources of the failure, So, but sometimes since the failure investigation will be running for a longer period of time, so in order to avoid the possibility that none of the points are left out from the analysis, so in order to ensure that all the aspects related with the failure possibilities are investigated thoroughly, and thereafter only well informed conclusions are made regarding the fundamental sources regarding the primary causes of the failure, it is good to know about the questionnaire which is normally used, for failure analysis. So, this questionnaire helps in the two ways. One is that it avoids the possibility of overlooking of some of the aspects, and the second one is that it also gives the directions or the areas which need to be explored during the failure analysis. So, these are the two aspects. One is the directions oblique areas which can be investigated as per the case, and the second is avoids overlooking of some of the aspects related with the failure. So, these are the two important things related with the setting of the proper questionnaire for the failure analysis. Reduces the possibility of overlooking of some of the aspects related to the failure analysis, and the second is it will have the better clarity on the ways and the directions which should be investigated, so that well informed conclusions can be made during the failure analysis. So, now we will be talking about the different questions that need to be asked at the end of the failure analysis to see if if we have looked into the various aspects of the failure analysis or not, if some of the points are still missing and which needs to be addressed or which need to be seen. So, there is a proper checklist of the questions which we need to ask. So, the first thing is that we need to ask if the sequence of the events which have led to the failure has been established or not, and if not, then we need to see that what we need to see what information need to be gathered additionally, so that the sequence of event of the failures, sequence of the failure or sequence of events which have led to the failure of particular component can be established. The second aspect is have we identified the location where from the fracture or the crack was initiated and which eventually caused the failure. So, the initiation of the fracture or the crack location has been identified or not, that is the second aspect. Third is if there was a cracking and eventually the fracture has led to the failure, then whether the crack was located at the surface or in the subsurface region. So, there may be possibility that crack would have been there right from the beginning and not due to the surface conditions. So, that also can be easily distinguished, like if there is a crack which is present at the surface or if the crack is present inside the component here in this form. So, the crack which is exposed in the atmospheric conditions, so that will have the effect of the atmospheric gases, may be in form of the oxides, nitrites, etc. It will show the different color shades and presence of these compounds, which also can be characterized using suitable techniques like XRD to see what kind of the oxides and nitrates are present, and their thickness also can be measured, which can be used to see for how long the crack has been present here. But if the crack is inside, it will not be under the exposure of the atmospheric gases. So, the fracture surface of the, so basically in this case surface of crack will be nascent, will be clean, will be metallic, and it will be free from the oxides, nitrites. So, although this kind of the crack, so the crack which are present at the surface and which are present in the subsurface region, they will look different. So, we need to identify also if the fracture has been caused due to the cracking. So, whether the cracks were present at the surface or in the subsurface region. Also, we need to establish if there was any role of the stress razor in facilitating the crack nucleation. So, these stress razors may be in form of like the toe of the weld or the location where change in cross section is taking place, or some keyhole or any other keyway or any other kind of hole is present which is acting as a stress razor. And the third, so next aspect is if there was a crack, then for how long it has been there before fracture occurred. So, for determining how long crack has been there, we need to do the measurement of the thickness of the oxide layer which is present, or oxide which may be form of rust or any other form of any other oxide or any other compound. So, based on the rate of oxidation reaction for a given metal, we can identify for how long crack has been there. So, like say this is the metal surface, and depending upon the thickness of the oxide layer and using the kinetic rate of the oxidation reaction, we can determine for how long the crack has been there at the surface. So, the next step is if the fracture has been caused by the cracking, and the cracking has occurred either due to the stress razors or it has been there in at the surface for long, then for how long crack has been there before fracture, that can be checked through the thickness of the oxide layer if it has been exposed. Then next is the intensity of the load. There are two possibilities regarding this. There can be overloading fracture. So, as far as intensity is concerned, we need to see the service data regarding the kind of the magnitude of the load which is expected, and using the service and using the information about the cross sectional area of the component, we can determine the kind of the allowable stresses which should have been there. But sometimes by seeing the fracture surface and especially the microscopy of the fracture surfaces, there are certain features which indicate if there has been overload fracture. So, overloading, if overloading has been accidental or abnormal loading has taken place, then if that has caused the fracture, that also can be identified. So, intensity of the load can be understood from the two ways. One is whether there has been overloading or there has been repeated loading under which the fracture has taken place. So, in this case, of course, under the repeated loading conditions, the load magnitude will be lower than the yield strength limit, yield stress of the material, and in overload fracture the material will be subjected to the stresses greater than the ultimate tensile strength of the material. So there are two ways to determine the intensity of the loading. One is to see the possibility of the abnormal loading or accidental loading, or also another one is to see the macroscopy and microscopy of the fracture surface to see if there has been a repeated load which was lower than the yield strength limit, or if there has been the overloading which have overloading which has caused the fracture of the component. Then the type of loading also is to be identified from the service data record. We can identify if the loading has been the static or it has been cyclic in terms of the completely reversible or tensile to tensile or the fluctuating loading. So, that information also need to be identified under the to see the possible conditions under which failure has taken place. Then next aspect is to find out also to mention about the kind of stresses which have caused the failure of the component, and these may be in form of like tensile, shear, bending or things like that. So, because the fracture surface will indicate the kind of the loading or the kind of stresses under which the failure has taken place. For example, in case of the tensile load, dimples typically show the perpendicular dimples grow perpendicular to the fracture surface, while in case of the shear loading they are inclined, while in case of the bending also the inclination is of the different type. So, the shear fracture surfaces will have the orientation of the dimples in the different ways on both the sides, while in case of the bending it is also the different. Just by using the principles of the microscopy of the fracture surface, we can identify the kind of stresses which were there. So, sometimes people speak as per their convenience to hide the information, but the microscopy of the fracture surface can indicate the kind of stresses under which the component has been exposed during the service and under which failure has taken place. Then determination of the fracture mechanism and or the failure mechanism is also important. We need to see if the failure has taken place due to the excessive loss of the dimensions due to the wear, or the fracture or the failure has taken place due to the plastic deformation, either loss of the mechanical properties or any other reason. So, whether there has been the loss of dimensions, plastic deformation or elastic deformation beyond the acceptable limit, or there has been complete fracture or separation due to either overloading or repeated loading or loading under the fatigue conditions. So, the failure mechanism is to be identified. Another important thing is that it is also to be identified whether the temperature at the time of failure has been identified or not. This is important because if the temperature is different from the ambient condition, then in either way, whether the temperature is high or low, it will be affecting the mechanical properties of the component, which will increase the tendency for the failure. For example, the high temperature will be reducing the yield strength of the material, ultimate strength of the material, however it will be increasing the ductility. On the other hand, the low temperature, so this is high temperature. On the other hand, low temperature conditions will be leading to the increase in yield strength, increase in ultimate strength also, but reduction in ductility percentage elongation. At the same time, significant loss of the impact resistance also takes place. So, those components especially which are sensitive to the temperature, and if they are subjected to the transition from ductile to brittle behavior, then it is very important to mention the temperature at the time of failure. So, we need to identify basically the temperature at the time of failure has been specified or identified or not. Then we need to also see whether if there has been any role of the wear in failure and which has degraded the dimensions of the component, and the change in the dimensions of the component will be leading to the size and the shape of the component. So, sometimes change in shape of the component does not lead to stop the working of the system, but it reduces the efficiency of the system. So, even a malfunctioning of the component can also start. So, due to the wear, there can be change in size and shape of the component, which can increase the tendency of the getting inappropriate results or reduce the performance. So, that can be considered as a failure. So, the role of the wear is to be identified in the failure of the component. Similarly, if the failure has been caused by the loss of dimensions, so we need to see if the loss of dimensions has occurred due to the corrosion, and if the corrosion is the possible cause of the failure, then what type of the corrosion, whether it is crevice corrosion, pitting corrosion, galvanic corrosion, or it is the general corrosion under which failure has taken place. The next is the conformance of the material with the specification. We know that the components are expected to perform under a given set of conditions, and that can be expected only if they are made of a particular kind of the material as per the design requirement. So, it is important to see that if the failed component was made of the material as per specification or not, and for that we need to confirm the chemical composition of the failed component, so that it can be established that if there was if the failure has been contributed by the discrepancy or the deviation in chemical composition. Since the chemical composition of the material directly affects the structure of the material, and which in turn affects the mechanical properties response to the heat treatment, and therefore chemical composition is important. And so, through the chemical analysis of the field component, we will be able to know really if it has been conforming to the specification or not. So, the another question is we need to identify whether it has been identified or not that the composition of the material is conforming the specification or not. Then next is the class of the material. Class of the material is identified with regard to the percentage or the amount of the allowable deviation in terms of the composition or the discontinuities, which may be in form of the dissolved gases or inclusions or in terms of the mechanical properties, toughness, ductility, etc. So, these will be indicating the class of the material. Like one common term is very generally used, like the premium quality metal or the commercial grade. the metals. So premium quality metals are much better as compared to the commercial grade metals. So that is also general classification for public understanding, wherein which is generally based on the kind of the concentration or the percentage of the gaseous inclusions or the mechanical properties and microstructure of the material. So, in addition to the class of the material, we also need to see whether the component design was perfect or not, and for that it is required to see the load resisting cross sectional area of the component. If the load resisting cross sectional area was appropriate or not for a given service conditions, that is to be identified through the design analysis of the design aspects. And then we also need to see if there has been any role of the material specifications on the failure aspect. So, this we need to see with regard to the like material specification, means whether the material chosen for making a particular component was appropriate or not. So, this may be in terms of the chemical composition, mechanical properties. This may also be in terms of the corrosion resistance, wear resistance as per the case. So, whatever material has been chosen had required the mechanical properties or not, that is what is identified, and efforts are made to establish if there has been any role of the material specifications or material properties which have been used for making a particular component on the failure. Then also we need to see if there is any role of the mechanical properties were appropriate for a given application, given service conditions or not. For example, a material to be used or component to be used under the low temperature conditions must have required fracture toughness, it must have the required the toughness also, so that it has a good resistance to the impact fracture. At the same time, its ductile to brittle transition temperature has to be lower enough than the service temperature conditions. Similarly, for the high temperature conditions, we need to see whether it has required creep resistance or not, it has required hardness at elevated temperature or not, it has required resistance to the deformation, means yield strength at the service temperature conditions or not. So, as per the service requirement, whether the material properties were appropriate or not, that is what is identified through this one. Then the role of the heat treatment, which means if the component has been subjected to the heat treatment, whether that heat treatment was proper or not. So, the possibility of the inappropriate heat treatment is also to be explored if it has been subjected to the heat treatment, and its possible role on the failure of the component, which may be in terms of the steel which should have been normalized, instead of the normalizing, if it has been spheroidized, then it will be showing very low hardness or very low strength, and although increase in ductility will be there. So, reduction in hardness and strength can degrade the performance significantly. Similarly, instead of the normalizing, if it has been air hardened, say for and normalizing was carried out for by putting in air, but due to the higher alloying element in the steel, say if it has been air hardened, so that will be leading to the martensitic transformation, and which can make the steel brittle, and therefore we have to identify if the component has been heat treated in the manufacturing stage, whether that heat treatment was proper or not. So, that possibility is also identified. And then possibility of the improper manufacturing, which means that whether the correct kind of process has been used or the process parameters were appropriate or not. So, various aspects related to the manufacturing has to be explored and identified, and in order to see if they have inappropriate manufacturing has in any way contributed towards the failure. Then the possibility of inappropriate or improper assembly is also identified, and for this purpose we know there is a proper assembly procedure. If the assembly is improper, then it can lead to the issues related to the related with the misalignment, or it can lead to the absence of the some of the components which were required for proper functioning of the component. So, if there is a failure also need to be investigated with regard to the possibility of the inappropriate or improper assembly. Then it is also important to consider if the failed component has been subjected to any recent repairs. Sometimes repair means like if a component has shown some kind of crack during the service. So, it is obvious part that it will be repaired. So, if the crack has been there and it is repaired. So, repair procedure has to be developed properly, and if the repair procedure is not proper, then it will lead to the additional stress raisers, additional discontinuities, and which can further be source of the failure. So, it is important to consider if there has been repair or not, if the repair has been properly carried out or not, or the repair procedure was properly established or not. And so, the possibility of the failure from the location where a recent repair has been carried out is to be explored. Then we know that whenever we use any new component, it is subjected to the somewhat lower load and lower service conditions, so that it can be used to work under those set of the conditions, and it is not subjected to any overloading in the beginning. So, if the proper run in conditions have been applied for the new component, that is also to be seen. Inappropriate run in conditions can lead to the initial stage failure of the component. Then the possibility of the lubrication and maintenance is also to be explored. So, for this purpose we need to see when the maintenance was carried out, whether the properly maintenance was carried out at regular intervals or not, and if there was any lubrication issue, then correct kind of lubricant was used or not. Or so sometimes the wear related failures are sometimes caused by the absence of the proper kind of the lubricant, or too long delay in proper feeding of the lubricant, or inappropriate use of the inappropriate lubricant. So, we need to see really if the failure has been caused by the inappropriate maintenance and the lubrication related issues. Then we also need to see the possibility of abuse in service, which means the component is subjected to for certain conditions. If it is expected that component will work under set of working conditions, but instead of that, if it has been exposed to some other set of working conditions accidentally, then that possibility is also to be explored. So, the another question that needs to be asked is the possibility of the abuse in service need to be explored, which may be in terms of the environment, and it may be in terms of the temperature conditions, it may be in terms of the loading conditions, which may be like a static load or dynamic loading, or the type of stresses also. So, because the component is to be used, or the product has to be used as per the design, because every component is designed for certain set of the working conditions, and if it is used under another set of the service conditions, then there is a possibility of the failure of the component. So, that possibility is also established. Then we need to ask that if really the design has been perfect or not, or is there a possibility to have much better design with regard to the factor of safety, with regard to the material which has been used, with regard to the design geometrical aspects of the design. So, various questions are asked to see if design can be improved further, so that the possibility of the similar kind of the failure can be avoided. We also need to see really if what will be the possibility of the similar kind of the fractures or failures to occur, that also to be asked, so that the future failures can be avoided. The last question here is like what is to be done to avoid the repetition of the failure. So, in this case we tried based on the potential causes of the failures which have been identified through the failure analysis. We also try to ask really what are the specific things which can be done so that the failure in future can be avoided. Now here I will conclude this presentation. In this presentation basically I have talked about the set of questions which a failure analyst should ask so that the various aspects related to the failure can be covered, and none of the important points are overlooked in during the failure analysis. Thank you for your attention.